What's up? Welcome back to another video with me, Miss V. I am a geometry teacher, and today we're going to be talking about base angle theorem. So if that's something you're interested, go ahead and stay tuned for the rest of this video. If you have not already, please go ahead and subscribe to my channel so you can continue to see more geometry videos. I post every week, so if you guys want to stay tuned and keep up with your geometry classes, go ahead and subscribe down below and like this video so that I can get more students to see my videos, because I want to help as many geometry students as I possibly can. So without further ado, let's go ahead and get started. As I said, today we're going to be talking about base angle theorem. And before we jump into what base angle theorem is, there's a couple of things that we need to know. So base angle theorem basically says that in an isosceles triangle, the base angles of the triangle are congruent, okay? What base angle theorem more or less says is, we know that in an isosceles triangle, and I'm going to go ahead and draw an isosceles triangle for us. Okay, so we know that an isosceles triangle is a triangle that has two congruent sides, okay? So two sides in that triangle are congruent. Let's call this triangle ABC. So what base angle theorem really says is, if you look at the two congruent sides of that isosceles triangle, the angles that are opposite from those congruent sides, let's pick a lighter color green. So this angle, which is opposite of that first congruent side, and then this angle over here, which is opposite or across from that other congruent side, those angles are also congruent to each other, okay? Mind you, it doesn't mean that the side and the angle are congruent. No, it just means that these two angles are congruent to each other if the two sides are, okay? So this theorem only works for an isosceles triangle. It doesn't work for any other triangle. And for an equilateral triangle, since you have three congruent sides, an equilateral triangle, it's just going to be all three angles are going to measure 60 degrees. And we can talk about that another time, but that's more of like a definition, okay? So base angle theorem. I'm going to go ahead and prove this theorem. And in order to do that, I'm going to draw a picture for us. So let me go ahead and draw another isosceles triangle. Okay, and I'm going to call it triangle ABC. And what I'm going to do is, from point A, I'm going to go ahead and drop an altitude, okay? And I'm going to call this point down here D. So AD is an altitude, okay? That is an altitude, or we can say it is a perpendicular bisector, but I don't want to call it a perpendicular bisector because I don't actually need to, okay? So in order to prove this, I'm going to be given some information, okay? So I'm going to be given that AD is an altitude, and I'm also going to be given that triangle ABC is an isosceles triangle, okay? Because in order to use base angle theorem, I have to have an isosceles triangle. So ABC is an isosceles triangle, and usually it'll tell you which side is the base, okay? So CB is the base, okay? Which means that CB is the base, that segment at the bottom, right here is the base. That's the side that is not congruent, okay? That's like you can think of the base as basically what's holding the triangle up, I guess, but not really. Just think of it as just the side that isn't congruent, okay? So that means AB and AC will be congruent, okay? So with that given information, I'm going to go ahead and I'm going to do a 2-column proof with this. So I'm going to have some statements and reasons, and I might actually have to move this to the second page down here. So let's have some statements and reasons down here. Statements and reasons, okay? So my very first statement is going to be that triangle ABC is an isosceles triangle. Isosceles triangle with CB as the base, okay? And as always, this is a 2-column proof. So in 2-column proofs, this is your first statement is always gonna be whatever information is given to you. You can always split up this information, but in this case, and in this case I will. You don't always have to split up the given information, but here I will, because knowing that ABC is an isosceles triangle and knowing that CB is the base, right? Like I already said, now we can say that AC and AB are congruent to each other, okay? So AC is congruent to AB, and this is just based on the definition of an isosceles triangle, okay? So this is just the definition of an isosceles triangle. All right, and now I had another piece of given information, okay? And by the way, I forgot we were trying to prove that angle ACD is congruent to angle ABD, which are the base angles, okay? Because that's what Base Angle Theorem says, okay? So now from here, I have a second piece of given information. So this was the first piece that I used. Now this is the second piece, which is that AD is an altitude. So I'm going to go ahead and write that as my third statement. AD is an altitude. And again, that was just a given piece of information, okay? And I notice with my students, sometimes it confuses them that we can just say these things. But if they give you that information, you can just run with it, okay? You don't have to have like a specific, you do have to have a specific reason to say different kinds of things, but if it's a given piece of information, your reason is just given, like they just gave you that information, okay? So now, AD, this segment right here is an altitude. An altitude is basically a segment that when you drop it from a specific point, so I'm dropping it from point A straight down, it's going to form a right angle, okay? So an altitude means that it's going to form a right angle. It's perpendicular to the segment that it intersects. So AD and CB are perpendicular to each other, which means that now we formed right angles here. And I can write that as my next statement. So angle ADC is congruent to angle ADB, I'm guessing. Yep, ADB. And this is going to be because that is the definition of an altitude, okay? Definition of altitude. And you can also say that they're both right angles. So they're both right angles. All right, we're almost there. So now so far I have a side, this angle here, okay? And I'm also going to notice that this side right here, let me change the color. This side AD is congruent to itself, okay? So let's say if I were to split these triangles, right, into two separate triangles. So I have one smaller triangle over here with ACD, and then the other one over here with ADB. Notice here, AD and AD is the same exact side on both of those triangles. So you can say that those triangles share that side, which means that my next statement could be that AD is congruent to AD. And what we call this in geometry, this is the reflexive property. The reflexive property of congruence, which is basically you saying that something is congruent to itself, okay? All right, so I realize saying that AD is an altitude actually is not enough information to prove that these triangles are congruent, okay? So I'm gonna let AD actually be a perpendicular bisector instead of being an altitude, because as I noticed while I was doing this proof is that since AD is an altitude, the only thing that I know is that it forms a right angle here, right? Now looking at these two triangles, we have a side in common, another side, and the angle, this is SSA. We do not use SSA to prove that triangles are congruent, okay? So saying that AD is an altitude is not enough information. So instead, I'm going to let AD be a perpendicular bisector. So doing that, perpendicular. Okay, so that is the definition of perpendicular. We can leave the fifth statement as is, and now we can add another statement here. So since AD is a perpendicular bisector, we already took care of the perpendicular part when we said that there's a right angle here. The second part is the bisector part, which means that it's going to cut this segment into two equal pieces. Okay, so this line AD is going to cut CB into two equal parts. So the bisector part means it cuts into two equal pieces. So now I can say that CD is congruent to BD, and this is by the definition of bisector. Okay. And finally, my last statement, I can say, well, my almost last statement actually. Now I can say that a triangle ACD is congruent to triangle ABD, ACD, ABD. Okay, and to clarify this, make sure when you're naming the congruent triangles that you're passing in the same exact order. So for example, to go from A to C, I had to pass this pink congruent marking, which means that the corresponding triangle, I'd have to go from A to B, so I can pass that same pink marking, okay? And we can say that that's true by side, 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 because all three sides in that triangle were the same. And now finally, we have gotten to what we were trying to prove, which is that angle ACD is congruent to angle ABD. And this is by CPCTC. Corresponding parts of congruent triangles are congruent, okay? So now since I said that this triangle is the same as this one, these angles are the ones that match up with each other. That's basically CPCTC when you're saying these are the corresponding parts that match up, so they also have to be congruent, okay? So this was one proof of base angle theorem. There's actually another way to prove it, but I think I actually went through the second way to prove base angle theorem in one of my previous videos. It would have been on proving triangle congruence. And I didn't necessarily say that it was base angle theorem, but as you watch the video, you'll notice that that's exactly what I did. So go ahead and take a look at that video. I have it linked or somewhere up here, so you can just click on it. But as of now, I am done. So if you guys enjoyed this video, go ahead and subscribe to my channel so you can continue to watch geometry content. And I will see y'all in another video. Bye, y'all.